Okay, so 3 problems to get you started on this tricky worksheet. If you read the directions at the top, it talked about triangle ABC and how you were going to order the sides from least to greatest, okay? Now, in order to do that, we need to know the angles from least to greatest so that we can use our hinge theorem or our unequal sides theorem or one of those. And so I need to set up this problem. Now, this is talking about exterior angles, so I'm going to go ahead on my picture and draw exterior angles so I can put things in the right spot. So A, the exterior of A is 184 minus 9x. Measure of angle B, that means it'll just stay on the inside. Measure of angle C, exterior, 2x plus 112. Okay, so now there's several ways to do it. What I like to do is work on the inside of the picture because I'm very comfortable with the fact that the inside's going to add up to 180, right? So what I'm going to do is figure out what is this angle and what is this angle by using the supplement right here. So if I can take 180 and subtract all of this, it will get me what's inside, right? So let's do that. Let's take 180 and subtract all of that. Now, when you do this, don't forget to distribute that negative, okay? And then whatever this is, it looks like a negative 4 plus 9x. This is what I'm going to stick in this angle. I'm going to do the same thing over here, right? Ooh, I deleted something. Okay, the same thing over here. If the outside is 2x plus 112, then the inside is just the supplement of that. So I just need to subtract that from 180 as well to get myself to the interior. So let's distribute the negative, and 180 minus 2x, 180, I can do these together. So 180 minus 112, I believe, is 68. So this will be a 68 minus 2x. And I'm going to stick that right here. 68 minus 2x. Okay, great. Now I have 3 angles on the inside. Of course, they add up to 180. So here we go. I'm going to combine like terms. I've got 4x's, 9x's, and negative 2x's. That's going to come together and make, is that 11? Hold on. 4, 13, that's 11x. Okay, then I'm going to take all my numbers, negative 16, negative 4, there's a negative 20, and a positive 68, and that's going to equal 180. So I'll just continue to solve from here. Excellent. Divide that 132 by 11. I've got 12. Okay. All right, so x is 12. Now, we're far from done. We did all that setup just to get that x was 12. I'm now going to go plug all these back in to figure out what in the world they actually are. So 4 times 12 minus 16 is 32. That'll go up here, or not really up here. That's inside the triangle. I'm just all out of room. This bottom left corner, A, let's find A, negative 4 plus 9 times 12. That's a 104. Obviously, the picture is not drawn to scale. This is the part that we learned that. And then I'll plug this in here. 68 minus 2 times, what was that, 12? So this is a 44. All right, so we have all 3 of the interior angles of our triangle. And if I want to know the smallest side, it is opposite the smallest angle. So 32 is the smallest. So whatever's across from B, AC would be my smallest. It's going to be smaller than the middle one. The middle one will be across the middle angle. So what is that, AB? And then that's going to be smaller than the largest, which is across from this, so BC. And that would be, whew, finally done with that one. Moving on. All right, I'm not going to do this whole thing. I'm just going to get you started. If you read this, draw a triangle, labeling the vertices ABC. AB is 3x. BC is x minus 3, and AC is 3x plus 2. Using the triangle inequality theorem, solve for the possible values of x. Okay, basically, you guys just have to remember, if I had put numbers here, the triangle inequality theorem is the one that does the whole, like, the sum of any 2 sides must be greater than the third. And so that's all I'm going to do. 3 separate equations. First, I'm going to say, well, I know this one and this one. If I add those 2 together, I know that they have to be greater than the third side, and then I'm going to solve. I know that now I'll move to 2 more. So that's those 2 together. Now maybe I'll do these 2. The sum of those 2 has to be greater than the third side. And then in red, what have I not done yet? These 2 together. So with all of these, it's not necessarily hard. It's just how to start the problem, but once you do it, it's just going to be a whole bunch of algebra to solve for x in all 3 of those, and then you will have it. And then the last one is this crazy picture that I'm probably going to have to look at a little bit to figure out. So let me see what we have here. Okay, so I got 7 and 7. Let me just mark what I see. I know, let's see, I got this is a 6, so those match, and those match, and maybe that'll help me with something. It sure will. Okay, once I marked what was congruent on the picture, I don't know if you guys see it, but this triangle here is now going to be not congruent to, but sort of related to that one because they both have 2 similar sides. This is the problem I'm going to use the hinge theorem on. So it's almost like you kind of have to envision if this thing flipped around and all that. I'm going to focus on the 103 in this obtuse angle and the 7x minus 5, this obtuse angle. And what I'm going to do is just try to figure out like which one's supposed to be bigger. Now if they were both 9 or both 10 across from it, you know, then I would say they were equal. But since 10 is bigger than 9, the hinge theorem tells me that the angle 7x plus 5 must also be bigger than the angle in here. So that's got to be bigger than 103. So I know this to be true. So let me go ahead and solve for x here. Does that go evenly? I don't think so. Let me go ahead and get a simplified 50, oh yeah, math. Okay, 108 over 7. Gosh, that's ugly. Is that really happening to us right now? Oh my gosh, it's not. I can't subtract. Sorry, I'm dumb. Back to the step. Okay, minus 5 minus 5. So that's going to be a 98. Haha. That's so much better. And that actually is just going to be a nice pretty number. X has to be bigger than 14. Now this, what did it even want? I don't have the directions in front of me. I assume it said something about what is the range of values that this can be. You know, keep in mind that we know X has to be bigger than this. So what we've just found is we found the minimum is what we've just found. So we found x's minimum, but how do you find x's max, right? Well, the max is, since we're inside of a triangle, the maximum angle would be 180, okay? So we somehow have to figure out, like 180 has to be the absolute max, and since we already know that this one has to be greater than this one, I can set up a thing that says, hey, this is the bigger one, but it still can't be bigger than 180. So I'm setting up a second inequality to figure that out. Minus 5. So 175 less than 7x. 175 divided by 7. So 25. So x has to be between 14 and 25. That way these angles will actually make sense inside the picture. So hopefully that's enough to get you guys started. These are not easy, but we can definitely talk about them next week, and good luck to you.